Hey, this is problem 2 off of worksheet 5B, and it's one of our system of equations problems. So it says at Carl's Canby Diner, there are 3 sizes of coffee: a regular that contains 300 milliliters, a large that contains 500 milliliters, and an extra large that contains 800 milliliters. They cost $2.25, $3.25, and $5.75. respectively. One afternoon, the diner sold 37 coffees. The total volume of the coffee was 19,100 milliliters. The amount of money made was $133.25. So now we have to come up with some equations to write. So the first equation we're going to write is just the total. So how many coffees did we sell? We sold 37. So I'm going to write an equation for the total, x plus y plus z. The total number of coffees is 37, and I'm going to have defined x is going to represent what we're going to call our regular. So how many regular coffees we sold. Y is going to represent our large, and Z is going to represent our extra large coffees. So that's how many of each. So we sold a total of 37, and that's equation 1. Equation 2, we're going to write a money equation. So I'm going to go up and look at our money. So the small or the regular size is 225. So that means my second equation is going to be, I'm trying to squeeze it in here, 225x plus my large coffee is 325, so 325y plus my extra large is 575. They sound like Starbucks prices, which they probably are. That's a 5. Z, and that equals the monetary value, which we sold $133.25 worth. So that's going to be 133.25. Okay, then we have a volume problem. So the volume of each. So we have 300 milliliters for the small, 500 milliliters for the large, and 800 for the extra large, and our total volume is 19,000 milliliters. So my final equation is going to be 300x plus a 500y plus 800z. And what is our total volume in milliliters? For some reason, that is the craziest Z I've ever seen. It zigzagged on me. Okay, Z. And that's going to be 19,100. And there are our 3 equations. So what does the matrix equation look like? Well, we're going to have a coefficient matrix. We're going to have a variable matrix. And the variable matrix is always a column with, in this case, x, y, and z. And then we're going to have our solutions matrix, which is also a column, and that's going to be, let's go ahead and fill this in, 37, 133.25, and 19,100. Now, obviously, you want to use a calculator with this because these numbers are big. So our coefficient matrix will be 1, 1, 1 for the total, the coefficients for this first equation. The second equation is 2.25, 3.75, or 3.25, sorry, 3.25, only $1 more to upgrade, and then 575, $5.75. And then our volume is 300, 500, and 800. And that's our matrix equation. So then we're going to go back and put the coefficient matrix into the calculator as matrix A, a 3 by 3. We're going to put the solutions matrix in as B, which is a 3 by 1. And then to solve it, we're going to type in A inverse times B. That's always how you solve it. Coefficients inverse times the solution matrix. And we should be able to get our answer that way. Now, I'm going to just glance. I don't know what it is off the top of my head, what the solution is, but it is posted and you can go look at it. But that is the process to solve those.